Hello students, now we are going to learn how to solve the important 2-mark questions in the exercise 4.1 in trigonometry chapter for class 12 students. So these are all the important and frequently asked 2-mark problems in the examination point of view. So please be careful in listening, and before going to the problems, if you don't subscribe our channel, just subscribe it and click the bell icon so that you can get the updates immediately. Okay. So now let's move on to the important 2 marks problem in the exercise 4.1. So the first important problem is the question number 4. Find the value of sine inverse of sine 2 pi by 3 and sine inverse of sine 5 pi by 4. Okay. So let's solve the first subdivision first. Okay. That is sine inverse of sine 2 pi by 3. So to solve this, first we have to solve the function inside the bracket. So we have to simplify as much as possible this function. Okay, that is sine 2 pi by 3. Let's take the sine 2 pi by 3. So this can be written as sine pi minus pi by 3. Okay, because 3 pi minus pi by 3 will be 2 pi by 3. So that we have written this 2 pi by 3 as pi minus pi by 3. Okay, so now what is the value for sine pi minus theta? So your sine pi minus theta is your sine theta. Okay. Therefore, the sine pi minus pi by 3 can also be written as sine pi by 3. Okay. So now let's substitute the value for the sine 2 pi by 3 in the problem so that you can get sine inverse of sine 2 pi by 3 is equal to sine inverse of sine pi by 3. So here your sine and sine inverse will get cancelled so that your answer will be pi by 3 alone. Okay. So that your value for sine inverse of sine 2 pi by 3 is equal to pi by 3. Okay. So likewise we can solve the subdivision 2 also. Okay. That is sine inverse of sine 5 pi by 4. Okay. So now like in the previous problem, we are going to take this function inside the bracket, that is sine 5 pi by 4, which can be written as sine of 5 plus pi by 4, because 4 pi plus pi by 4 is equal to 5 pi by 4. So that this can 5 pi by 4 can also be written as pi plus pi by 4. Okay. So now what is your sine pi plus theta? Your sine pi plus theta is your minus sine theta. So that this can be written as minus sine pi by 4. Okay. So now let's substitute the value for sine pi 5 pi by 4 in the problem. Therefore, sine inverse of sine 5 pi by 4 is equal to sine inverse of minus sine pi by 4. Okay. So now here also your sine and sine inverse will get cancelled so that your answer will be minus pi by 4. Okay. So this is the value of sine inverse of sine 5 pi by 4. Okay. So now we have found the values for sine inverse of sine 2 pi by 3 as pi by 3 and sine inverse of sine 5 pi by 4 as minus pi by 4. Okay. So to solve this, you have to know only one thing, which is sine pi minus theta is your sine theta and sine pi plus theta is your minus sine theta. Okay. So that's all a very simple and easy problem only. So let's move on to the second important problem. That is question number 6. Find the domain of the following. F of x equal to sine inverse of x square plus 1 by 2x and g of x equal to 2 sine inverse of 2x minus 1 minus pi by 4. Okay. So first let's find the domain of f of x. Okay. So f of x equal to sine inverse of x square plus 1 by 2x. So first to solve this, first you have to know what is the domain of sine inverse of x. So what is the domain of sine inverse of x? That is minus 1 less than or equal to x less than or equal to 1. Okay. So this is the domain of sine inverse of x. Okay. So here in place of x, you are having x square plus 1 by 2x. Okay. So we can substitute this value in place of x. Okay. That is minus 1 less than or equal to x square plus 1 by 2x is less than or equal to plus 1. Okay. So this can be now subdivided into two parts. That is, the first part is this term, that is minus 1 less than or equal to x square plus 1 by 2x, and the second part is this one, that is x square plus 1 by 2x less than or equal to plus 1. Okay. So here in the first part, the value of x is x will lies in the interval minus infinity to 0. So the second part, x square plus 1 by 2x less than or equal to plus 1, lies in the interval 0 comma infinity. Okay. So let's solve these two equations to get more about the value for x and the domain of f of x. Okay. So this minus 1 and plus 1 are going to be taken to the left hand side and right hand side respectively. Okay. So first we will take the minus 1 to the left hand side. So x square plus 1 by 2x plus 1 is greater than or equal to 0. So now let's take LCM and move this 2x to the right hand side, so that your answer will be x square plus 1 plus 2x is greater than or equal to 0. Likewise, the second condition, that is x square plus 1 by 2x minus 1 is less than or equal to 0. So here also you are going to take LCM and move this 2x to the right hand side, that is x square plus 1 minus 2x is less than or equal to 0. Okay. So now this x square plus 1 plus 2x can also be written as x plus 1 the whole square, which is greater than or equal to 0, and x square plus 1 minus 2x can also be written as x minus 1 the whole square, which is less than or equal to 0. So now we have the two conditions, x plus 1 the whole square greater than or equal to 0 and x minus 1 the whole square less than or equal to 0. Okay. So these are all the two conditions. The first condition, in the first condition your x will take the values from minus infinity to 0. Therefore, we can substitute x as minus 1. Okay. So if you substitute x as minus 1, minus 1 plus 1 will be 0. Therefore, 0 greater than or equal to 0. So the condition satisfies. Okay. So the second condition lies in the interval 0 to infinity. Okay. So that you can take the x value as 1. If x is 1, 1 minus 1 is 0. Therefore, 0 less than or equal to 0. So that this condition also satisfies. Okay. So your x will take the values of minus 1 and plus 1. Okay. Therefore, the domain of f of x is minus 1 comma plus 1. Okay. So that's all about this problem, and to solve this you have to know what is the domain range of sine inverse of x only. Okay. So let's move on to the second subdivision. G of x is equal to 2 sine inverse of 2x minus 1 minus pi by 4. Okay. So to solve this you have to consider the sine inverse of x term alone. So other things you can ignore. Okay. So sine inverse of x will have the domain range of minus 1 less than or equal to x less than or equal to plus 1. So that in place of x you are having 2x plus 1 here. Okay. So that minus 1 less than or equal to 2x minus 1 less than or equal to plus 1. Okay. So this can also be divided into two parts, that is minus 1 less than or equal to 2x minus 1 and 2x minus 1 less than or equal to plus 1. Okay. So let's take this minus 1 to the right hand side, so that your 2x minus 1 plus 1 is greater than or equal to 0, and this plus 1 can also be taken to the left hand side, so that your 2x minus 1 is less than or equal to 0. Okay. So minus 1 and plus 1 will get cancelled, so that, and here minus 1 will be minus 2. Okay. So here 2x is greater than or equal to 0. So here 2x minus 2 is less than or equal to 0. And here x is greater than or equal to 0, because 2 has been taken to the right hand side, so that x is greater than or equal to 0. And here 2x is less than or equal to 2, because this minus 2 has been taken to the right hand side, so that 2x is less than or equal to 2. So x is less than or equal to 1. So by cancelling 2 on both the sides, we will have x is less than or equal to 1. So from this we are having 0, x is greater than or equal to 0 and x is less than or equal to 1. That is 0 less than or equal to x less than or equal to 1. Okay. So that your domain of g of x will be 0 comma 1. Okay. So that's all about this problem. Very simple and easy problem. So only thing you have to know is sine inverse of x range is minus 1 less than or equal to x less than or equal to plus 1. Okay. So let's move on to the next important problem. The question number 7 in 4.1 exercise. Find the value of sine inverse of sine 5 pi by 9 cos pi by 9 plus cos 5 pi by 9 and sine pi by 9. Okay. So like in the previous problem, we are going to take this function inside this bracket first. solve this and apply this in the problem. Okay. So sin 5 pi by 9 cos pi by 9 plus cos 5 pi by 9 sin pi by 9. So this is in the form sin A cos B plus cos A sin B. So what is your sin A cos B plus cos A sin B? That is sin A plus B. So that here your A is 5 pi by 9 and B is pi by 9. So that this can be written as sin 5 pi by 9 plus pi by 9. Okay. So what is this? This is 6 pi by 9. Okay. So sin 6 pi by 9. So this can be written as sin 2 pi by 3. So this sin 2 pi by 3 can also be written as sin pi minus pi by 3 like in the first problem. So sin pi minus pi by 3. So sin pi minus theta is your sin theta. Therefore this is sin pi by 3. Okay. So that the function inside this bracket will be resulting in sin pi by 3. That is sin 5 pi by 9 cos pi by 9 plus cos 5 by 9 sin pi by 9 will be equal to sin pi by 3. Okay. So let's substitute this value of sin pi by 3 in place of this function. We will get is equal to sin pi by 3. Therefore, sin inverse of sin 5 pi by 9 cos pi by 9 plus cos 5 pi by 9 sin pi by 9 is equal to sin inverse of sin pi by 3. So here your sin and sin inverse will get cancelled. So that your answer will be pi by 3. Okay. So the whole function will be resulting in the value of pi by 3 only. Okay. So that's all about this problem. So to solve this you have to know only one thing, that is your sin A cos B plus cos A sin B is equal to sin A plus B. Okay. So that's all about this problem, and these are all the important 2 mark questions that are frequently asked in examination in the exercise 4.1 in inverse trigonometry functions chapter. So if you have any doubts and questions, please mail me to yadamkeli20@gmail.com, and if you want any more problems to be solved in this exercise, please comment in the comment section. Okay. Thank you.